Good morning, guys. Welcome back. I am going to be doing our notes for today. So this first one is actually derived from what you guys were doing yesterday. So if you felt confident on the notes yesterday, go ahead and pause this so you can go over it now. If you were a little bit confused, no worries. You can, follow along with me. So I just want to kind of break down graphing quadratics. I know she did this in the video, but just for those who were maybe a little bit confused by that video, the root of our graphing quadratics actually comes from like a typical graph of them. So if I graphed this, like how I graphed really anything that we're a little bit confused about graphing, we can always make a table to graph it. And theoretically, we can make a table to graph every single one of these problems. But there's a shortcut we can use to graph them, and that was that 1-3-5 or step method that they showed you yesterday. So we've done these tables before, and we've graphed with them. When we use them, we typically plug in the values -2, -1, 0, 1, and 2. Okay? And I'm going to not start at the normal place. I'm actually going to start with 0 and just talk about that really quickly and then move from there. So if I plugged in 0 to this equation, I would have 2 times 0 squared. So this is f of 0. This is what happens if I plug in 0 for x. Well, if I plug in 0 for x, f of 0, this is the f of x format, 2x squared. F of 0 is the same thing as saying y. It's just another way to write it, but it's helpful to see it both ways. So if I plug in 0, what it's saying is I get out 0. So I get this point 0, 0. And then we can plot that there. Okay. So 0, 0 in this case is my 0 of the graph. Or remember how they gave us some definitions where it crosses the x-intercept are called solutions, they're called roots, then they're called zeros. So that is that point. 0, 0 is also my vertex of this graph. And a lot of you were getting confused yesterday. You're like, I got some emails. It's like, how is the vertex supposed to be 0, 0 on all of these, or am I messing it up? And the vertex is 0, 0 on your homework yesterday for all of them. And the reason why is because like our traditional quadratic graph, and I think you did one of these where it's just like y equals x squared, it goes through the point 0, 0. So if I'm going to multiply that by anything, when I plug in 0, it's still just going to give me 0. So this one is just x squared times 2. Well, 0 times 2, we can see over here, is still just 0, right? So if I plug in 0, I still get 0. Now that's not going to be true if I'm adding or subtracting, because 0 plus 2 is no longer 0, it's 2. But if there's nothing adding or subtracting to my quadratic, my vertex is 0, 0. Okay, so maybe put that somewhere in your notes. If nothing is adding or subtracting I'm just going to put a subtraction sign. 2x squared. The vertex is 0, 0. Now something can be multiplying. Like it could be 2 in front or 1/2. But that's kind of our basis. All right. Now let's talk about the step method, and then we'll kind of do this 2 ways. So my step method says I should take the points 1, 3, 5, and in this class we're mostly just going to focus on 1, 3. So I should take the points 1, 3 and multiply them by a. And a is our value in front of x squared. So in this case, a is 2. So we take 1, 3, we multiply them by 2. That 2 distributes through, and we get 2, 6. So I had the 1, 3 method, and now I have the 2, 6 method. And what this says is I always go left, right, 1 from my middle. So remember how we would do rise over run in the past? And we would go how far up, how far down. Well, in this case, my run is always going to be left, right, 1. So I'm always going to go left, right, 1. My rise is what changes. So in this case, I'm rising 2 because it was 2 in front. Okay, so left, right, 1, rise 2. This same thing would happen if I plugged into the table. If I plug -1 in, I get 2. If I plug -1 in, I get 2 times -1 squared. Well, -1 squared is 1. 2 times 1 is 2. So I'd have the point -1, 2. And if I plugged +1 in, I would get 1 squared times 2, which would be also 2. So we can kind of see I had the point -1, 2 and the point 1, 2. And that's what we have happening here. -1, 2, 1, 2. Okay, so the same points are going to happen when I create a table. It's just this 1, 3 method is a little faster. All right, next one, I'm going to rise 6. So I always go left, right, 1. But in this case, I'm going to rise 6 instead of rising 2. Oh man, I lost my points. 1, 2, 3, 4, 5, 6. So getting all the way up to 8. All right, we would see that same thing if I plugged it in. If I plugged -2 in, I would get f of -2 equals 2 times -2 squared. Well, -2 squared is 4, and 2 times 4 is 8. Okay, and that would happen for +2 as well. So here's how we can do it using our table. Here's how we can do it using the 1, 3 method. Both ways work. We're going to mostly be using the 1, 3 method because it's a little bit faster. And last thing we're going to do is just finish sketching these graphs. And I saw on your guys' homework from the other day, so some of you were a little bit confused about what the shape of this graph needs to look like. Oh my goodness. It should look kind of like a U. So here we can see it's kind of the shape of our quadratic. Okay, and it's going to go on forever. All right, and that is all we do. And this one wasn't asking for the axis of symmetry, but I know on your homework it was. So let's just write it out. I like to denote axis of symmetry as AOS, axis of symmetry. And axis of symmetry is always in the equation x equals, because the axis of symmetry is a line that goes through the vertex, and it's a vertical line. Remember back in like our first unit when we were graphing just y equals mx plus b, if I had a vertical line, it was always x equals instead of y equals. And it's always x equals the x value of my vertex. So in this case, we have x equals 0. Cool. All right, that is graphing quadratics. Our first bit there. Cool. Let's go ahead and move on to the next problem. You can always pause this video or rewatch this if you got a little bit confused. And the next bit I want to talk about is our shifts. So we've talked about shifts before, and that this next form that we're going to talk about is called the vertex form in a little bit. And if we understand how graphs shift, it will help us understand vertex form a lot better. So we can see my typical graph is x squared, right? So that's my original, y equals x squared. Oopsies. Okay, so that's my typical graph, y equals x squared. In this case, I'm adding 4 to it. So because I'm adding 4, plus is always a shift. So plus always is a shift. And if it's happening on the outside, it's a vertical shift. If it's happening on the inside, it's a horizontal shift. So we kind of, if we compare 2 and 3, we can see 2, it's adding on the outside of x squared. 3, it's adding on the inside. It's like occurring directly to the x. So this is happening on the outside. So it's vertical. Okay. And then we talked about how vertical shifts are just intuitive. So plus, if you're thinking, it just makes sense, right? If I'm adding, what do we expect that to do? Go up or down? And I expect that to go up. If I'm subtracting, we're going to expect that to go down. Okay? So this is our shifts. So in this case, I added 4. So I am going to have my graph go up 4 units. So my vertex in my previous graph was 0, 0. Now if my vertex is going up 4 units, instead of having a point at 0, 0 like I did last time, it's going to go up 4. 1, 2, 3, 4. So now if I plugged in 0 for x, I would get out 4 for my y. And we can see that here. If I plug in 0 for x, 0 squared is 0 plus 4 is 4. So this is my vertex. Okay, that's going to be my vertex. My axis of symmetry is always going to be x equals my x value here. So x equals 0 in this case. So if I go to graph it, we're just going to use the 1, 3 method. We'll multiply by a. A in this case is our number in front of 1. So a is just 1 in this case because is the number in front of x squared. So a is just 1 because there's no number in front of x squared. So we take 1, 3, we multiply it by 1, so we get 1, 3 again. So I always go left, right, 1. In this case, I'm going to go up 1. Always go left, right again, 1. In this case, I'm going up 3. Okay, so this one kind of barely fits on my graph, but we can still see it here. And that's all we have to do for those. Okay, so that's the benefit of using the 1, 3 method. Like, we don't really need a table. If we can notice the shift, we don't even need to, like, finding our vertex can be pretty easy too. So let's look at this next one. Maybe pause the video, see if you can figure out what the vertex is, determine what the shift's going to be, what's happening here. Okay, hopefully you paused the video and gave it a try. Since this 3 is subtracting on the inside, it's going to be a horizontal shift. And remember how horizontal was counterintuitive. So that means it doesn't do what we expect. So for horizontal shifts, plus goes left and minus goes right. So if I have a negative, it's actually moving it in the positive direction. So this is actually going to move it in the positive direction. So my new vertex, since this is horizontal, it's changing my x value. So my new x is not going to be -3, it's going to be 3. And my y value is still 0. So it's taking my point, which was 0, 0. It's moving it 3 units in the positive direction. So till right here. That's my vertex. My axis of symmetry in this case is x equals that y value still, which is x equals 3 in this case. All right. In this case, the a would be actually in front of the parentheses here. And since there is nothing in front of the parentheses, a is just 1. So once again, we'll take 1, 3. We'll multiply it by 1. That just gives me 1, 3 again. So from this point, we're going to go left, right, 1, up 1, left, right, always 1 again, and then up 3. So the 1, 3 is just my rise. I'm always running 1, both to the left and the right, but the rise comes from 1, 3. Okay, and then we can graph this. Good. And there we have it. Our graphing quadratics, just based off the fact that they're shifting. Okay, the next form we're going to do is called vertex form. And it's the same idea. I have a horizontal shift and I have a vertical shift happening. So let's do this first one, kind of the way we did the previous ones, and I'll show you a shortcut for the next two. So, same idea. We can see I have 2 shifts occurring here. The second one is adding on the outside, so that's going to be a vertical shift. And since it's plus, it goes up 2. All right, the first one here is adding on the inside, so that is our horizontal shift. And remember how we said plus goes left? So it's going to go plus is left 2 units. So if my original point was on the vertex, and also some of these, you see how it's like counting by, this is like 1/2. So don't get confused by that. You count a whole unit. So it's going to go up 2 to get to my new vertex, and also to the left 2. So this is my vertex. I'm going to just erase this extra stuff. So that's my new vertex. So my vertex in this case is, I went to the -2 to the x and +2 in the y direction. So that means my axis of symmetry is always x equals that x value there. So it's just x equals -2. All right. So now we can go ahead and graph it, right? Left, right, 1. We need to do the 1, 3 method. Sorry. The number in front was 1 again, so it's just going to stay 1, 3. So always left, right, 1. Up 1 for the first one. Always left, right, 1 again. It doesn't matter what your A is. You're always going to go left, right, 1. And then we're going to go up 3. Cool. And we can go ahead and graph that. Cool. So hopefully like something like this. Draw your arrows on the top. And call it a day. Okay, maybe pause this next one. Try to do it on your own. And then we're going to do it together. Hopefully you paused it. I'm going to write out, this is our vertex form of the, what's it called? Parabola. So this is my vertex form of the parabola, and the reason why it's called vertex form is because it gives me the vertex, which is so handy. Because when I'm graphing these, I know we talked about how we have to use the 1, 3 method, but the purpose of the vertex is it's the turning point of my parabola. So you can kind of see here, the vertex is my turning point of the parabola. So it turns, the parabola turns around the vertex. So I have to find the vertex before I can do the 1, 3 method. If I found this point and then did the 1, 3 method, it wouldn't be right. The parabola wouldn't look right. So if I can find the vertex, then after I find the vertex, I can use the 1-3 method and get all my points on my parabola. But I can't do that without knowing the vertex. So the vertex is actually super important for us. It's like the one point we have to know in order to graph this. So, with that being said, the vertex, it's a really handy vertex form because it gives us the vertex. The vertex in vertex form is the opposite of h comma k. So, I know these values are kind of weird, but this h value actually represents the x value of my vertex. This k value actually represents the y value of my vertex. So in this case, the opposite of h, we see h here is 1, so the opposite of h is negative 1, and k is going to be 2. So we switch the sign on the x value and leave the y value the same. And we were actually doing that already, because remember how we said, oh yeah, it's a horizontal shift, it's going to the left, so it's actually going in the negative direction. That's where that same negative 2 came from. Okay, so we switch the y value on the sign on the x, leave the y value the way it is. So this is my new vertex, negative 1, 2. So let's plot that point. We can still use the 1-3 method to graph this. There was no number in front, so my a is just 1. Okay, so I'm just doing 1, 3. I'm not doing different numbers. So we always go left, right, 1. And now we're going to go up 1. We always go left, right, 1 again. And now I'm going to go up 3. And up 3. Okay, so when we graph it, we should get something that looks something like this. Cool. So the vertex form even speeds it up a little bit more because it tells us which way it's shifting in order to get my new vertex. So let's do 2 more and then we'll call it. Right, yeah. For this next one, vertex form, my vertex is the opposite of h comma k. So find your vertex real quick. Okay, we should see h is this first value, so it's the opposite of negative 2, which is positive 2, comma k is my y value, so that's just going to go in there. So if my vertex is 2, 4, oopsies. That's going to be my vertex. And now we're going to use the 1-3 method to graph it. There's no number in front in this case, so it's just 1. So 1 times 1, 3 is just 1, 3. So we're going to go left, right, 1, up 1. Left, right, 1 again, up 3. 1, 2, 3. And then you just follow in the points. Okay, if this is still a little bit confusing by the end of these notes, send me an email. I'm more than willing to hop on a Zoom with you guys, help you out, help you with your homework. Let's look at this last one. Once again, my vertex, and you guys should be emailing me your homework. I've gotten it from a handful of you, but not everyone. My vertex is opposite of h, so negative 3, comma 3. Maybe pause it to graph this one on your own and then come back. Okay, welcome back. We get negative 3, 3 is my vertex. Okay, we're using the 1-3 method. So I'm taking 1, 3, multiplying it by 1 because there's no number in front here. So that's 1, 3. So keep in mind, A is the number in front. So today, none of the problems I gave you had like an A, just that bell work. But starting tomorrow, you're going to have an A in front. So you'll have to multiply by something different. So going left, right, 1, up 1. Going left, right, 1 again, and this time up 3. 1, 2, 3. Cool. And you can go ahead and graph that. Oh, those are the prettiest. It's okay. Cool. And that's all we have to do to graph. So find the vertex, use the 1, 3 method. That's how we'll do all of these. And you can even use the vertex form on these type of problems like 2 and 3. For 2, we can see there's nothing adding to the x, so my x value, my h is just 0. But there's something adding to the y, so my k is 4. Number 3, nothing's adding to the y, but I have something adding to the k. So my h is 3, but my k is 0. So you can use the vertex form to do something like 2 and 3, but if you prefer it the other way, you can do that too. Okay, your homework's posted in Google Classroom. Good luck.